All right, today we're going to talk about the number E. Not the letter E, but the number E. All right, so the number E is a real number. It is an irrational number, which means it goes on and on and on forever, similar to pi, except that it is not a radical. And the value of E is approximately 2.718. So E is kind of known as the natural base, and you'll see that when we get into logs a little bit more. And it's going to be used in equations where there is continuous growth, which we'll be doing in the next couple of days. All right, so let's take a look at how do we simplify E. So if I have e to the third times e to the negative 5, I'm going to simplify this like I would simplify any exponent that had the same base. I'm going to add those exponents. So this would be e to the negative 2. I don't want to leave a negative exponent in my answer, so I'll write this as 1 over e squared. Feel free to stop the video and try these on your own, but I'm going to continue. 3e to the fourth squared, well, I have to square the 3, so that'll give me 9. And e to the fourth squared will be e to the 8. If I'm going to simplify a radical, I can rewrite this as e to the 6th times e. E to the 6th is a perfect square, so e to the 3rd times the square root of e would be simplified. Let me take care of this denominator, but if you remember, when I have division, I'm going to end up subtracting my exponents. So here I'd have 8e to the 5th in my numerator. 2 squared would be 4, and e to the negative 3 squared would be e to the negative 6. If I simplify my numbers, 8 divided by 4 is 2. Remember, this negative sign is saying, I don't want to be in the numerator. Please move me into the, I don't want to be in the denominator. Please move me in the numerator. So I'm just going to bring him up and call that e to the 11th. And then that's going to be simplified. Again, feel free to try these on your own and then come back and listen to the video to see if you have them right. But I will continue. I'm going to add these exponents. This will be e to the 7x, 3x plus 4x. I'm going to multiply my numbers, so 1/2 times 6 would be 3. E to the negative 3x times e to the 5x would be e to the 2x. And that's simplified. Here I have no other numbers, or you can consider that I have a 1 there, so that would be 2e. Well, 3 and negative 2x, those are unlike terms, so all I can do is just write it as e to the 3 minus 2x. I'm going to simplify these radicals. You're going to simplify 18 just like you would as if it was alone. You can break it up into 9 times 2, e to the 2x. Well, 9 is a perfect square, but also e to the 2x is a perfect square. So I can bring that out as 3e to the x, and I'll have the square root of 2 left. I can break up e to the 5x as e to the 4x times e. E to the 4x is a perfect square, so I can take this out as e to the 2x times the square root of e. And here when I'm dividing, I'm going to subtract my exponents. Again, they are unlike terms, so I'm just going to leave it as e to the 5x minus 3. You can also use your calculator to evaluate e. So I'm going to put e squared in my calculator, 3e to the 1.2, and 5.2e to the negative 0.6. So if you go to your calculator, you can see there are a couple of buttons here where you can use e. One of them is right here above this natural log button, so you'll have to go second. And you can see up here it says e to the x. Or also above this division button is also e, so you can go second division. I like to use this one because it's already raised to an exponent, and all the ones that I'm going to be working on here have an exponent. So if I simply go second e and squared and hit enter, you can see that this is going to be 7.4. That's kind of an important number. We'll be using that quite often when we'll be graphing. The second one I want to do is 3e raised to the 1.2, and I have 9.96. And the last one is 5.2 times e raised to the negative 0.6, and I have 2.9 or 2.85, depending on how you want to round. All right, let's talk about how do we graph these functions now. So this is still an exponential growth function. Remember, if I had something next to the x, like +2 or -3, that would be my horizontal shift. And if I had something over here, that would be my vertical shift. We also know that that would be my asymptote. But since I have nothing here now, we know that actually my x-axis is going to be my asymptote. If we do an xy table for at least the first time that we're going to be graphing these, we'll pick the numbers that we usually do, 0, 1, 2, -1, -2. All right, if I plug in 0, well, e to the 0 is going to be 1. We know that that's always going to be on our graphs. E to the 1 is just simply e, which we know is about 2.7. E squared is, we saw from when we put it in the calculator, it's about 7.4. E to the -1 is just going to be 1 over 2.7, and e to the -2 is just 1 over 7.4. I'm just going to be estimating these values on my graph, so I don't really care exactly what these decimals are. I just know that it's going to get me closer and closer to my asymptote. So if we were to graph this, I have 0, 1. I have 1, 2.7, and I'll just estimate it about there. And 2, 7.4. 1, 2, 3, 4, 5, 6, 7. Right about there. -1 is going to be 1 over 27 and 2.7 and 1 over 7.4. So I know I'm just going to come down like this, and I'm going to get closer and closer to my asymptote, and my graph will look like that. Let's take a look at what it would look like if we did have some of those shifts. So once again, we know that this +3 is going to be my asymptote. So let's go ahead and just write it in right now. And this right here is going to be my horizontal shift, and it's always the opposite sign, so it's going to be +2. So I know that right there is going to be my starting point. From here, we know I'm going to have 0, 1. If I go over 1, I'm going to have 2.7. And if I go over 2, I'm going to have 7.4, which would be up somewhere there on my graph. -1 is going to get me closer and closer to my asymptote. So I'm just going to come down and around like this and hug my asymptote like that. And the last one we want to shift is graph is if we have some shifts and some flips. So here again, this -4 is going to be my asymptote. 1, 2, 3, 4. Right here is my asymptote. And now if I do an XY table, 0, 1, 2, -1, -2. If I plug in 0, I'm still going to get 1. If I plug in 1 now, it'll be e to the -1. So now I'm going to have 1 over 2.7. If I plug in 2, I'm going to have 1 over 7.4. If I plug in -1, I'll have e to the -1, which is e to the 1, which would be 2.7. And then this here would be 7.4. So now if I graph that, I'm going to graph it actually from this point. I have no horizontal shifts. So 0, 1. 1, I'm going to, over on this side, I'm going to get closer and closer to my asymptote. If I have -1, I'll be at 2.7. If I have -2, I'll be at 7.4. 1, 2, 3, 4, 5, 6, 7.4. And now you can see this is going to create a flip because it's going to go in the other direction. And that's really all you need to know right now about E. Please let me know if you have any questions.